So we're very privileged tonight to have Dr. Elizabeth Lynch. She's the medical director and owner of the Sleep Institute of New England over in Kingston. She also has a lot of experience in bioengineering, pulmonary medicine, human nutrition, geographic medicine and infection disease, and newborn medicine. So my gosh.
Thank you so much for having me here tonight. It's interesting, she introduced me and it took me sort of back in time, 20 or so years. I started out as a researcher after undergrad, almost 30 years ago now. And I was in Boston doing some research in geographic medicine, infectious disease. I did my master's with newborn medicine, master's in bioengineering, and then I went on to medical school. And I have been up in New Hampshire for approximately 10 years now. My training is internal medicine, pulmonary critical care medicine, sleep medicine, and within pulmonary you get a little sleep and a little bit of allergy. So I'm somewhat well versed in a few different areas. And the Sleep Institute of New England primarily does sleep medicine, but I'm also doing pulmonary and allergy there as well. The purpose of the lecture tonight is to learn about the physiology of sleep, to understand the health effects of poor sleep, recognize sleep disorders and when to refer, potentially, and I refer for sleep studies and management through case studies, so I have a couple of case studies, and to understand, the last two slides are just to understand some of the changes in medicine and how it might affect optimal health care for the patient. So, normal sleep physiology, in general, we have a third of our time spent asleep. Why? I don't think anybody really knows exactly why we need it, but we think we need it because to restore our brain, our functions, to reset ourselves for the next day, and to be able to perform well during the day. There are two types of sleep. There is non-REM or NREM, and there is REM sleep. REM stands for rapid eye movement sleep. And it is when we dream. So it's either sort of that non-dreaming state versus a dreaming state. There are three stages of sleep, and there's of non-REM sleep, three stages of non-REM sleep, stage 1, 2, and 3. Stage 1 and 2 are light sleeps, and stage 3 is deep sleep. And then in REM sleep, that's a whole stage by itself, so technically there's about 4 stages of sleep altogether. Now you will see, if you are up on the literature, you will see actually that there are 4 stages of non-REM sleep, stage 1, 2, 3, and 4. However, about 3 or 4 years ago, they consolidated stage 3 and 4, which is deep sleep, and they just call it stage 3 now. So you might read older literature, and even when I was preparing, stage 3 and 4 is still talked about in the literature. But anyway, that's deep sleep. Each stage of sleep is unique, has unique characteristics, and we alternate through both of the stages of sleep, the non-REM sleep and the REM sleep, throughout the night. And we get about 4 to 6 cycles of sleep per night. This is a typical appearing night of sleep. So usually you enter sleep through stage 1, so that's light sleep, and then you go to stage 2, and then you go into deep sleep, and then you come back up and you hit a little bit of dreaming sleep, and then you start the cycle again. Stage 1, down into stage 2, deep sleep, back up into a little light sleep, and then dreaming sleep or REM sleep again. And here you have about 4 cycles of sleep in that nighttime. So stage 1, it begins our sleep. It's usually a short period of time, a few minutes. Overall, throughout the entire night, stage 1 sleep is only about 2 to 5%, and it's characterized by certain EEG rhythm. So there's alpha waves, some theta waves, some low voltage and mixed frequency waves. And when we do a sleep study, this is how we stage sleep, is we look at your EEG activity. Stage 2 is another light stage of sleep. The initial cycle is 10 to 25 minutes. Cycle lengths successively increase, and total you get about 45 to 55% of your night in stage 2 sleep, so it's the largest amount. It's characterized by these things called spindles and K complexes, and sleep spindles are often thought to be involved with memory consolidation. Stage 3, which is that slow wave sleep, that deep sleep that I was talking about, occurs during the first third of the night, usually more so than the last 2/3 of the night. In the beginning of the night, it only lasts a few minutes, and then it progresses to sort of have longer and longer periods. And the second half of the night, we don't see a lot of the deep sleep. And it comprises about 15 to 25% of the total sleep time. And the EEG activity down here, right down here, you'll see these sort of big delta waves down in here. So big sort of waves, and that comprises the deep sleep. Dreaming sleep, or REM, rapid eye movement sleep, initially is only about 1 to 5 minutes, but it progressively gets longer and longer, and we have more dreaming sleep in the second half of the night compared to the first half of the night. It comprises about 15 to 25% also about the total sleep time, and we see rapid eye movements and bursts of this activity. We see dreaming, and we see muscle atonia. Atonia means no movement, so you are flaccid. You are not moving at all in dreaming sleep, completely still. EEG is desynchronized, it's low voltage, mixed frequency, and you often get these things called sawtooths on there on the EEG. Physiologically, we change in non-REM versus REM sleep in terms of our brainwave activity, our heart rate, our blood pressure, blood flow to the brain, muscle tone, airway resistance, body temperature, and sexual arousal. Everything changes. So in non-REM sleep, we see a lot of sort of decreasing of these things, and in dreaming sleep, we're increased, or it changes depending on sort of what part of the brain we're looking at. Sleep cycle is controlled by 2 processes. One is called process S, or sleep, or H. Sometimes you'll see an H, and that stands for homeostasis. And then it's also controlled by a maintenance of wakefulness, which is also called process C, and that stands for circadian rhythms. Process S, or that homeostatic drive for sleep, is defined as the need for sleep. It accumulates over the course of the day. I'm going to show you a graph so it looks a little, you'll sort of understand it a little bit better. But the need for sleep accumulates over the course of the day. It peaks just before bedtime, and then it goes away. This need for sleep just goes away after we have slept. And then with adequate sleep, our homeostatic drive for sleep is reduced by the circadian waking drive, which increases as we are done sleeping. Here's the circadian process C. It promotes wakefulness and alertness. It's regulated by the circadian system, so our light-dark cycle regulates this cycle. It builds across the course of the day. So when we wake up, our alerting signals aren't a tremendous amount because we have a lot of light. And then as we go through the course of our day, our alerting signals build and build and build, and it counteracts the process of sleepiness. It declines around bedtime, and it assists the sleep-wake cycle in synchrony with the light-dark cycles that we have. So here's a picture of that. So here we are, process S or process H, and you see here, this is 9 o'clock in the morning, and your sleep load, so your desire to sleep is low because you've just slept. And over the course of the day, your desire for sleep increases, 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 increases. It is counteracted by process C, by the circadian rhythm, where that process is low when we first wake up in the morning because you got bright light. The day is just starting and the sun is up and there's bright light. And over the course of the day, we increase our alerting signal to counteract this sleep need or drive that we are slowly accumulating. And then somewhere around 10, 11, 12 o'clock at night, this sort of shuts down, and then boom, we fall asleep and everything starts over. The sleep generating systems in the brainstem are regulated by neurons that shut down the arousal systems to allow the brain to fall asleep. Many neurons are found in the preoptic area of the hypothalamus. The loss of these nerve cells causes insomnia. But there's also inputs from the other brain areas that influences this area. Process C, the wake generating systems in the brainstem, is generated by ascending arousal systems from the brainstem, which is down in here. This is the pons in the medulla area down in here. I should actually go over here. Pons in the medulla area down in here. Activates the forebrain via two pathways. The first pathway is a cholinergic neuron in the upper pons area that activates the hypothalamus, and then the second one is in the upper brainstem to the hypothalamus. Now, you know, if you really wanted to get into detail, you could go ahead and read all about this, but I was just going to mention it and then sort of move on. I wasn't going to actually get into lots of detail here. The circadian rhythms are daily rhythms that we have in physiology and behavior. It controls our sleep-wake cycle. It's very much part of or influences our physical activity, food consumption, what we eat, when we eat, body temperature, whether it goes up or down, our heart rate, our muscle tone, and our hormone secretion. Rhythms are generated in the hypothalamus by a biological clock that we have in the hypothalamus, and it's regulated by these things called clock genes. There are two proteins called clock and BMAL1, and they are outside the cells, and what they do is they come inside the cell and they bind together inside the cell, and then they turn on these genes called period and cryptochrome. And those two genes go outside the cell, and then they bind together, exert their activity to promote wakefulness or sleep, and then they move inside the cell and they disrupt then the clock and BMAL proteins in here. And this cycle happens every 24 hours, and so it influences whether we're awake or asleep, and it's very dependent on light and dark. The suprachiasmatic nucleus is responsible for regulating circadian rhythms in all of our organs. Bright lights serve as a detector in the back of our eyes, in the retina of our eyes. When we see light, what that does is that it sends signals to the suprachiasmatic nucleus to reset these clock genes every day, the clock and the BMAL1. There are other genes, but those are sort of the two big ones. The suprachiasmatic nucleus transmits signals to the brain and the body, synchronizing our daily cycles and our day-night feeding, activity, hormone secretion. It also controls the secretion of melatonin. Sleep thermoregulation is involved in whether we are awake or are asleep. There is a decreased heat production that happens at nighttime, and that promotes us wanting to go to sleep. And as you see here at 11 o'clock at night, our temperature starts to decrease, and then it promotes us to want to go to sleep. An increase in body temperature disrupts sleep and promotes wakefulness. Up top here is your body temperature over a 24-hour period, so body temperature on the y-axis or the left side here. Right below that is serum cortisol level, and right below that is melatonin. And if you see here, right down here at the x-axis, it's 22 hours, so that's 10 o'clock at night, you can see that things start changing. Melatonin starts being increased around, 10 o'clock at night. So cortisol soon thereafter starts going up, and also at the same time, maybe even a little bit before, our body temperatures start going down. And then all of a sudden, boom, we go into sleep. And this is a regular daily thing that we don't even know is happening. And there's more to it than just this, but these are sort of the big ones, right? So sleep is important. It's got a very, very strong either waking or wanting to go to sleep. It's regulated internally, and it is coordinated with light and dark. Melatonin is a brain hormone that I had mentioned previously, and as you saw on the previous slide, it is increased. It starts to increase around 10 o'clock at night. It helps induce sleep. It helps decrease that waking drive. Remember that that process C I talked about just previously? Process C tries to maintain wakefulness. So melatonin starts to be secreted in your body about 9 to 10 o'clock at night, and it affects that waking drive. It sort of says, okay, let's not wake anymore. Let's want to be tired. We want to be tired now. And it makes that waking drive go away, and then boom, it allows you to go to sleep. The problem with melatonin is that we lose it over time. Down here, this is age. This is age. And look, when we're 50 years old, oh my gosh, where did my melatonin go? You know, they say the best years of sleep are between the ages of 6 and 12. So I have a 10-year-old and a 7-year-old, and I say, live it up now, guys. Live it up now. This is the best sleep you're going to get. They don't know what I'm talking about. But anyway, so it's a bummer, but you know, when we get older, we don't make as much melatonin, and I'm going to touch on why, or not why, but what happens with sleep as we get older. So, how much sleep do we really need? So when we are tiny, you know, newborns, we're sleeping 12 to 18 hours a day. When we're toddlers, we're 12 to 14 hours a day. When we're school-age kids, we're about 10, 11 hours a day. And adults, interestingly, still need about 7 to 9 hours a day. Sleep and aging. So what happens as we get older? So unfortunately, we decrease the total amount of sleep that we get. It takes us longer to fall asleep. We end up going to bed a little bit earlier, and we might wake up a little earlier. We don't have as much deep sleep, that's stage 3 sleep I was talking about. We don't have as much dreaming sleep or REM sleep. The threshold for waking from sleep is less, meaning it's easier to wake up out of sleep, to be disrupted. If the cat jumps on the bed, if there's a noise in the other room, you know, it's sort of easier sort of to wake up from sleep from that. Our sleep becomes more fragmented, and we often do daytime napping. Right, so this is unfortunately what happens with age, right? Here are your sleep patterns over the course of time. So here you are, a 10-year-old down here, and over here, 75-year-old. And if you look at the distribution, you know, here's stage 2 sleep, and you see it's less, you know, over here. Here's that nice deep sleep, that slow wave sleep. Look at that over here. We're not getting nearly as much. Dreaming sleep, same thing. Much more dreaming sleep here compared to here. And then WASO means wake after sleep onset, right? So my 10-year-old goes to sleep and he is out cold. Look at that, he's not waking at all. But here we are, over here, we're waking up all the time. And sleep latency just means how long does it take us to fall asleep. There's not a huge change there. This is that same graph I showed you before in terms of the normal stages of sleep that we get. And up top, this is children up here. Remember I said here stage 1 and 2 are the light sleep, stage 3 and 4 deep sleep, and you see we go down from light sleep into deep sleep and then dreaming, and then light sleep, deep sleep, dreaming, and then deep sleep, dreaming, you know, normal stage. Now that's kids. And then the second graph right in here, these are young adults. They end up actually getting a little bit more dreaming sleep as the night moves on, and a little bit more deep sleep maybe. And here are patients, I don't know, over 65, 75. You can see that it's much more disrupted. So there was a study looking at gender differences between men and women, and there are a few. This study, interestingly, noted that men needed about a little over 6 hours of sleep per night. That's what they reported. And women said that they needed a little bit more, closer to 7 hours of sleep per night. Men fall asleep quickly. They have an increased prevalence of snoring. They're more likely to have sleep apnea. They're more satisfied with their sleep overall, interestingly, and they don't have as many sleep complaints, but when they do say something, they talk about being tired during the day more than women talk about being tired during the day, and they tend to be more night owls. And women, they may fall asleep faster, they may sleep deeper. They have less disruptions overall, but they actually say that they have more insomnia. Why is that? Well, they could have a bed partner that snores, and clearly this is well known in the literature. You know, menstruation, pregnancy, menopause screws up sleep. It just does. You know, you wake more. But we tend not to say that we're very, very tired during the day. We just sort of move through it. And there's, interestingly, women tend to function better on tasks with sleep loss when compared to a man. And increased rates of sleep apnea after menopause, there is a connection between estrogen or the lack thereof, and sleep apnea. Don't know exactly what it is yet, but I would imagine if you stay tuned in another 20 years, I might have the answer for you, because there's just, copious amounts of research coming out in these areas. Let's talk a little bit about health effects of sleep deprivation. So there's a decreased performance and alertness. If you sleep 1.5 hours less, you will lose a third of your productivity. That's amazing. It truly is. It's amazing that if you get your 5.5 hours or 6 hours compared to 7.5 hours, you're not functioning as well as you could. And I went to a conference. I always go to the national conference every year. It was held in Boston in June this past year, Sleep Medicine International Conference. And I went to one of the lectures, and the gentleman said that there was a study done, and they looked at people who they gave everybody 8 hours of sleep for a couple of weeks, and then they broke that group into 3 groups. A group that got 4 hours of sleep, a group that got 6 hours of sleep, and a group that continued to get 8 hours of sleep. And they did that for 2 weeks. And they found that the group that had 4 hours of sleep clearly did not do well on their tasks. There was task performance that they had to do the next day, and they were, their task performance was much less. The 8-hour-a-night group did fine. That was normal. The 6-hour-a-night group actually had declines in their task performance. But here's the clincher. Over time of getting 6 hours a night, they lost the ability to know that they were performing less well. Isn't that interesting? Right? So we do perform less well. We just don't know that we're performing less well. All right. It also impairs memory, cognition. It stresses relationships. We are more irritable. We fly off the handle a little bit more. People report poor quality of life in general. There's a 2-fold increase in occupational injuries, and there's an increase in automobile injury. 100,000 crashes per year, 71,000 injuries, and 1,500 fatalities. And these are just the people that are actually admitting that they are driving tired, right? Because a lot of people aren't admitting that. Long-term health consequences of sleep deprivation, the list goes on and on. Increased mortality, increased blood pressure, increased risk of cardiovascular disease, heart attack, stroke, diabetes, increased risk of obesity, attention deficit disorder, alcoholism, mental impairment, and on and on and on. This slide, actually, I'm going to spend a little bit of time on this. If you look off to the right here, so this is looking from 1985 to 2004. And we're looking at men and we're looking at women. And the men are the white and the black, and the women are the lighter gray and the darker gray. And if you look here at any age, from, let's just look at the 45 to 65-year-old group. At any age, in 2004, we got more people, there were more people getting less than 6 hours of sleep compared to 1985. So for men, about 22% of men said they got less than 6 hours of sleep. And in 2004, about 33 or 34%. For women, about 22% got less than 6 hours of sleep. And then in 2004, about 32, 33%. So clearly, we are not getting enough sleep, and it's worsening over time. If you look at mortality in sleep, if you get 7 hours of sleep per night, you are at a lesser risk of dying compared to if you got less than that or if you got 10 hours. If you have a lower body mass index, you tend to sleep maybe a little bit better, 7, 8 hours a night, versus if you have a higher body mass index. If you sleep less than 6 hours of 6 hours per night, you have a higher prevalence or odds ratio of diabetes. If you have insomnia versus no insomnia, higher prevalence of depression, higher prevalence of anxiety, higher prevalence of alcohol abuse and drug abuse. Medications, we often don't think of this, but many people drink coffee, many people smoke cigarettes, many people have alcoholic beverages at night. Many people are on SSRIs, Paxil, Zoloft, Effexor, Lexapro, right? We see these all the time. These medicines are associated that can contribute to insomnia. And I've just circled a bunch of them that we see all the time. You know, a lot of our patients are on these. So the prevalence of sleep problems, this was a poll that was done in 2003. And they said that 74% of adults report difficulties with sleep a few nights a week, so say 3 nights a week. About 40% get less than 7 hours of sleep a night. About 40%, a little less than 40%, say that they're sleepy during the day and it may interfere with their activity. And that amounts to about 50 to 70 million Americans. The most common sleep disorders that I see, obstructive sleep apnea or other sleep apnea, so not just obstructive, there are other types, but sleep apnea is one. Insomnia, just run-of-the-mill insomnia. Shift work, circadian rhythm sleep disorder, right? Working night shifts or rotating shifts, you know, day to night, you know, first to second to third, and then sort of back around again. Some sort of movement disorder, like restless legs, something like that. Narcolepsy, which is a sleeping disorder, decreased production of orexin, which is a brain hormone, that you fall asleep easily at any time throughout the day. And then parasomnias, which include sleepwalking, sleep talking, confusional arousals, you know, bedwetting in kids. So there's a bunch of parasomnias that are out there. So I'm going to focus on just a few minutes on the 2 most common disorders, and then we're going to talk more in the rest of the talk about sleep-disordered breathing or sleep apnea and all of sort of the health consequences of that. So sleep-disordered breathing is the umbrella term for obstructive sleep apnea, central sleep apnea, mixed sleep apnea, any of the sleep apneas falls under what's called sleep-disordered breathing. They say about 18 million people have it, but I think that's probably more than 18. There's probably more than 18 million. It's about 9% of women, maybe 24% of men. In general, we think that it is due to being overweight. 4 out of 5 people, they have a little bit of weight on. But I'll be honest, I see people in my office who have relatively normal body mass indexes and they have sleep apnea. Prevalence increases with age. And then, as I said, there's different forms, obstructive, central, and mixed. Insomnia is the most common problem that's reported. And it's not uncommon. I would say at least 50%. I saw a patient today. At least 50% of my patients who come in say, I don't have sleep apnea. I just have a problem falling asleep and I have a problem staying asleep. But I don't have sleep apnea. But that's exactly what sleep apnea does. It gives you difficulty with falling asleep and